and this is section 4.2, addition/multiplication rule of probability. So first let's familiarize ourselves with basic probability. So P of A is equal to the probability that event A will happen given certain parameters, and this number has to be between 0 and 1, or it could be equal to either 0 or 1. So mathematically, probability of A equals the number of ways A can occur divided by the number of different sample events. In other cases, the probability of A is equal to the number of times A occurs divided by the number of times the procedure is repeated. So let's look at some examples of basic probability. So what is the chance of rolling a 2 with one 6-sided die? So the answer is the probability of rolling 2 is equal to 1 over 6 or 1.6667. Now, the probability is 1 over 6 because theoretically you have an equal chance of rolling any of the 6 numbers on a 6-sided die. So for each one, it'll be a 1 out of 6 possibility of rolling any number of a 6-sided die once. So let's look at the next example. If 13 of 16 patients testing a new medication experience improvement in their condition, what is the probability that a patient from the study noticed improvements? Let's look at the answer. So the answer is the probability that the patient improved is equal to 13 over 16. Now this is because there are 16 total patients, and there are 13 that improved within this study. So if you randomly selected one of the patients, there would be a 13 out of 16 chance of getting a patient who improved. Now let's look at the addition rule of probability. So in order to find the probability of one event or another event occurring under the same conditions, you have to add the probabilities together. So mathematically this looks like the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, with the probability of A and B being the probability that they occur together. Some other problems look like the probability of A or B is equal to the probability of A plus the probability of B, and that's it. That is provided that events A and B are disjoint, which I'll explain in the coming slides. So disjoint events. So disjoint events are two or more events that cannot occur at the same time. So some examples of this would be going to dinner in New York and going to dinner in Chicago. These two events can't happen at the same time. You can't be in two places at one time, so the events are disjoint. Another example would be winning the baseball game and losing the baseball game. So in this case, it's binomial. You can only win the baseball game or lose the baseball game, assuming that there's no ties. So these two events can't occur at the same time, and thus they are disjoint. So events that are not disjoint could possibly occur at the same time. So some examples of this would be going to work on Tuesday and also going out to eat on Tuesday. The time being that single Tuesday, and the probability of each is they could both possibly happen on the same day. Another example is meeting your friend Sally and meeting your friend Mark. So it's possible that you could meet both of these people at the same time, and thus it's not disjoint. Okay, so let's look at the addition rule. So a common problem that you have with the addition rule is finding the complement. So the complement is what is the probability that event A will not happen. So the probability of getting event A and not getting event A is always equal to 1. So to find the complement, the probability of A not happening is equal to 1 minus the probability of A happening. Or you could also look at it like the probability of A is equal to 1 minus the probability of A not happening. So an example of this would be the probability that it will rain on Monday is 0.337. Find the probability that it will not rain. So the probability that it won't rain on Monday is equal to 1 minus 0.337, which is equal to 0.663, this is because the probability of A is equal to 0.337, which is where you get this number from, and why you are subtracting 0.337 from 1. So More classic problem, another classic problem in the addition rule of probability. So in a survey of 51 people represented with the table, 10 of the participants were female, 3 of whom answered yes, with a total of 12 participants answering yes. What is the probability that a participant was female or answered yes? So because there is an or in the question, you know that it's a addition, the addition probability. Let's look at this. So your table, 3 females answered yes, 7 answered no, but there are 10 total females. 12 total people answered yes, 39 total people answered no, and 51 total people in this study. So let's look at the answer. And this is avoiding double counting. I'll explain what the double counting is after I go over the problem. So the probability that that it's female or yes is equal to 7 over 51 plus 12 over 51. And the answer is 19 over 51. So this 12 over 51, this comes from this right here. So 12 total people answered yes, and there are 51 total people in the study. So the individual probability of getting someone who answered yes in this study is 12 over 51. Now, adding that to the women, 7 over 51. In this case, it's just the women who answered no, because the women who answered yes are already included in this 12 right here. So, and because we're avoiding double counting, we just leave this out and just keep this as 12 as the total, and the 7 we just get the remainder of the women in the study, not the women who answered yes, because that would overlap with this one, with the people who answered yes. Let's look at another one. So what is the probability that the waiting time was at least 9 minutes or between 6 and 11 minutes? So looking at this table, you're going to know that because it says at least, you're looking at the probability of this of 9 all the way to 20. So you're adding all of these together. And then also between 6 and 11 minutes. So because it's between 6 and 11, starts at 6, ends at 11, adding these together divided by the total number of customers. So let's look at the answer. So the probability of A or B while allowing double counting is equal to 17 over 50, which comes from adding these numbers together divided by the total number of subjects in the test, plus 25 over 50, which comes from adding these two numbers together divided by 50, subtracting 11 over 50, because this section here is the overlap. This is the overlap that you need to get rid of. So this is the probability of getting 9 to 11 is 11 over 50. It's already included here. So it comes out to 31 over 50, or 0.62. That's your answer. So now let's look at the multiplication rule of probability. So in order to find the probability of one event and another event occurring, you have to use the multiplication rule. So mathematically, this looks like the probability of A and B is equal to the probability of A times the probability of B over A, where the probability of B over A is the probability that event B occurs given that A has already occurred. Or it looks like the probability of A and B is equal to the probability of A times the probability of B, provided that A and B are disjoint. So another important factor to look at when doing multiplication problems is dependent versus independent events. So if the order of the given events matters, then they are dependent events. So an example would be selecting marbles out of a bag without replacement. So selection without replacement means the events are independent. So in this case, the selecting marbles out of a bag without replacement, each marble that you take out, you're decreasing one of the marbles that you're looking for and also one of the total marbles. So it's a different ratio every time. The total number is different every time, so that needs to be accounted for in the problem. So each prior event affects the next event, which is why it's dependent. So then an independent example would be the political party of two random citizens living in a town. So this is independent because the political party of the first citizen has no bearing on the political party of the second citizen. It's just pulling randoms from a hat, and the population is already there, and it's each has no bearing on the other, so it's independent. So let's look at an example of the multiplication rule of probability. So example, in a town where all its residents are either Democrat or Republican, 73% of the town's residents are Republican. Find the probability that 3 randomly selected residents are Democrat. Okay, so the answer is the probability that 3 selected are Democrat are 0.27 times 0.27 times 0.27, or it could be 0.27 to the third power, if you would like. That comes out to 0.19683. Now, this is the way that it is because the sample is disjoint and each sample is independent, as explained earlier in these types of problems. The political party of the first candidate selected has no bearing on the political party of the second or third person selected. And it's 0.27 because 73% of the town's residents are Republican, so 1 minus 0.73 is equal to 0.27. So in this case, here's the chance of getting one, here's the chance of getting another, here's the chance of getting another. They're all multiplied to get 0.19683, and that is your answer. Let's look at another multiplication problem. So, out of a sample of 37 refrigerators, 2 of them came back defective from the factory. If 4 refrigerators are selected, what is the probability that none of them have any defects? Okay, let's look at the answer. So the answer is the probability of 4 great working order refrigerators, best refrigerators in the world, is equal to 35 over 37 times 34 over 36 times 33 over 35 times 32 over 34. Now, why is that the answer? So, we start with a 35 out of 37 probability because 2 of them are defective. So a 35 over 37 probability of getting a refrigerator with no defects. So assuming that that one has already been selected, the next one also would have to be one that is not defective. But because you have removed one of these refrigerators and you have removed one of these refrigerators, the ratio changes to 34 over 36. And it happens again and again the same way every time. It would be wrong to say 35 over 37 times 34 over 37 times 33 over 37, etc., because you're also removing one of the sample population, and that's important in this case. So this is all because it's a dependent sample, because none of the samples are being replaced. So let's look at one more multiplication rule of probability. So we have this table here, and if 2 men are selected, what is the probability that they are both light smokers? Okay, so because it's 2 men who are selected, you have to look at the population is the total number of men, not the total number of subjects in the test. You're just looking at men because that's indicated because it's saying 2 men are selected. What is the probability that they are both light smokers? Okay, so let's look at the answer. So the answer, the probability of 2 male heavy, sorry, I meant to light. 2 male light smokers is equal to 59 over 430 times 58 over 429. Now this is similar to the last problem. This is dependent because if you have one of the samples is found to be a light smoker, you're removing one of these subjects from the sample, bringing you to 58. And likewise, you're removing one of the subjects from the total sample of men, bringing you down to 429. Multiplying these two numbers together, you get 0.0186. So the samples are dependent because there is no replacement of the subjects. My name is Jake Hewig. Thank you for watching my presentation. I hope that it was helpful, and have a nice day.